Good afternoon, ladies and gentlemen. Welcome to the next 100 years of flying. Thank you so much for making time to be with us this afternoon. I'm PJ Maykish. I'll be your moderator. I'm pleased to introduce to you Amy Gowder, who's representing GE Aerospace, and Mark Valentine, representing Skydio. Sassie Duggleby flew in from Texas, Venus Aerospace, and Ken Taz-Plax is representing DARPA, Tactics Technology Office. So these experts are going to paint for us a picture today of what does the next 100 years of flying look like. If you think about it 100 years, in 1903, the Wright brothers struggled for 852 feet, and only 66 years later, Apollo 11 was on the moon. If you take 100 years after the Wright brothers, there's an MQ-9, a drone the size of an A-10 on the other side of the Earth with 9 hard points for 500-pound bombs. So that's what 100 years looks like, and that's what we're going to explore now, is what does the next 100 years look like? So for my panelists, if you could please tell the audience and open up the technologies that are in your portfolio right now. Ironically, GE is a company that has about 100 years of experience, and you're leading them now, Amy. Where is the tech in your portfolio, and what does it tell us about where flying is going?
Sure. Thanks for having me.
Yeah.
So first of all, GE Aerospace is really excited. We launched April 2nd to be a pure play, standalone aerospace and defense company. And it's not often that a company with 100 years of history gets to relaunch itself, right? So in our portfolio, we're obviously most excited about our adaptive engine technology. So we'll talk about that in the future, but it is here and now. We just finished our 4th round of testing, and adaptive architecture really is going to be an asymmetric advantage in combat for the Air Force in the future. We also, we share something with Sassie Hypersonics. We just finished another 3rd test in our hypersonics portfolio. And that portfolio, we came from concept to test in 11 months, which is an extraordinary time frame. So you are seeing cycles of development flourish. And then kind of the last thing I'll hit on is additive manufacturing has been a game changer for our company. It started in our commercial engines, and we've flown that with more than 1 million hours of flight time on our additive parts. We've translated that into our next generation helicopter engine for ITEP, and additive manufacturing has improved performance, obviously helped with supply chain issues. It's done things that you couldn't have done. So we're very excited about the technology itself, but also how we're making our products.
Fantastic. Mark, you're representing the drone community and autonomous flying. What is happening in your world to tell us where flying is going?
Yeah, it's a great question. First off, PJ, thanks for the opportunity to be here.
Absolutely.
Thanks for you all being here as well. When I think about the title of this panel, the next 100 years, that implies there was a first 100, which you talked about. And I was thinking about it. And I'm like, I know you and Ken as well. We spent a large part of that sitting in airplanes ourselves, which kind of seems quaint right now when I walk around this room. And so when I look at the first 100 years, I think the innovations were like in 2 bends. There was kind of the how of aviation, and then the what and the why. And in the how area, all the innovations were, go higher, go faster, go further. And there was new materials, new propulsion, amazing things that were needed. And then the why is, what could we do with airplanes? What meaningful use could we provide to humanity? And whether that was putting a camera somewhere so someone could make a decision, or moving people or things, we saw a lot of innovation in that area. But when I walk around this floor now for the next 100 years, what I see is we're living in a software-defined world in many ways. And so I think, what were the barriers to entry for humans using aviation capabilities in the first 100 years? And generally speaking, I think they were like cost and complexity. So, an average real estate agent was not going to go hire an airplane to take a picture of a house they wanted to sell, because it cost a gazillion dollars, and it took a really, really highly trained person to do that. And so the innovations that we're seeing in our space today are using the software-defined capabilities and AI to essentially democratize the ability to use aviation things to accomplish meaningful tasks. And I think what that's going to look like is a proliferation of drones being used in areas where pilots don't exist. Again, go to the real estate agent, go to the logistician using this autonomous drone that we create to autonomously fly through a warehouse and look at UPC codes to get in-transit visibility. We see it in the defense space, in the tactical ISR type use case. But we're also seeing public safety agencies use this, keep citizens safe. And it all comes down to the fact that when you can abstract away the really hard piloting skills and you're not worried about running the drone into something, now you can actually focus on the mission instead of the actual flying capability, and it really democratizes and makes more people drone operators. So it's the AI capability that I think is going to drive that marginal cost down and to see that proliferation move throughout humanity.
In some sense, we see this a little bit in Ukraine, the democratization.
Indeed. I just got back from there like a month ago, and yes, we're seeing it real time.
Sassie, we went from props to jet engines that have turbines. You have an engine that has no moving parts. In your portfolio, where do you see flying going?
Yeah, so I feel like we're one of the different groups sitting up here. So we're a small venture-backed startup. My husband and I actually co-founded the company to using a next-generation rocket engine to ultimately make 1 hour global travel. I mean, so how does the world change if you could get anywhere in under 2 hours? And that's the ultimate vision of Venus Aerospace. And it actually came because we were deployed to Japan, and living in Japan, like we had traveled internationally, but we had never realized how big the world really is. And so to me, the future is high-speed flight. It is anywhere in the world in an hour. It is, one of the advantages that we have with our engine is that because it's a rocket, we're carrying our own oxygen with us, which means that we can go way higher in the atmosphere. So I think high aerospace operations are coming down the pipeline, and that's going to change things. But ultimately, my hope and dream is to be able to, be in San Francisco, fly to Tokyo in 2 hours, have that meeting, and then come back and actually be home for dinner.
I'm a fan of that.
You're a fan?
That's a fantastic vision. No more jet lag.
No more jet lag.
I like it. It's a good vision.
Yeah.
The hypersonic economy is coming. I feel like I learned about it from listening to you.
Yeah.
It's really cool. Ken, you've been flying since you came out of the academy. Ken represents the Defense Advanced Research Projects Agency, very involved in the future of tech. We've had some cool programs that have come out of DARPA in the past. What are you working on now that you could tell the audience about where you see flying going?
I can't tell you anything, sorry. No, I'm noticing a couple trends. I run the Tactical Technology Office, which is where we build like airplanes and ships and submarines, kind of bigger projects. Previous stuff we did was AvBlue, Global Hawk was a DARPA program, Predator started as a DARPA program. So those are the kinds of things we do. And if we're doing our job right, we're building stuff that the service doesn't know that they want yet. For instance, when AvBlue came out, the Air Force wanted a bigger jammer. They didn't want stealth airplanes. And they're like, what are we going to do with this? Obviously, cooler heads prevailed. I see kind of three big trends coming. The first being kind of novel architectures. Right now, I've got something like 7 X-planes, different kinds of X-planes in various stages of development. The first one is the X-65, which we're calling the Crane, and it's using active flow control. So rather than having wing warping like the Wright brothers or ailerons actually deflecting and moving, what if you could build an airplane with no moving control surfaces and you're just using small puffs of air to control the boundary layer to maneuver the airplane? And so people have built toys before. And when I say toys, I'm talking, something that would fit on my lap. We're building a full-size, 7,000 pound, 20,000 foot Mach 0.6 type airplane using flow control for its control surfaces. In addition to the signature implications, if you could make a stealth airplane that didn't have to have moving parts, you could envision it being much more efficient, just cruising around. And then also potentially much higher lift instead of flaps and everything. So, shorter runways, quieter takeoffs, etc. Second one, we're building a heavy lift airplane for the maritime environment. A lot of the Department of Defense is looking at, if we had to defend Taiwan, how would you do that? And one of the big problems is what they call the tyranny of distance in the Pacific. And the Army and the Marines are looking at playing shell games on the islands. But if you take out the runway and you take out the port, they're kind of combat ineffective. So we're building a maritime logistics airplane, basically a seaplane that flies in ground effect. And when I say ground effect, I mean deep in 3D ground effect. You can roughly double the range of the aircraft if you do that. So you get ship-like volumes in airplane-like time scales. And because that wasn't hard enough, we're going to fly that in Sea State 4, by the way, right? Fly in Sea State 5, take off in Sea State 4, which is 10-foot waves. But that wasn't hard enough, so we're going to build it the way you build a boat, which cuts the price of the airplane roughly in half if we're successful. So that's kind of a different architecture and a different manufacturing process. Third one we're looking at, for a long time, all our airplanes have been tubes with wings. We've done blended wing body stuff in the lab, but never really built one. We're in the process of building one in conjunction with Special Operations Command that we call Sprint, which will be a vertical takeoff and landing, but then 400 to 450 mile an hour cruise, which is roughly twice as fast as a tilt rotor or a helicopter. We did the Quiet Supersonic Plane QSP program a while ago. NASA's working on that again. I think that there's a place to go fast, maybe not as fast as you, but fast. And then last thing we've had for new architectures, we're just finishing up a whole raft of both air breathing and gliding hypersonic vehicles that are now taking off in the services. I'm interested in ideas that could knock a zero off the price of a hypersonic system. That's about the bar that I would need at DARPA to start a new hypersonics program, because they tend to be expensive. So if you have ideas, I'm all ears.
Yeah, let's talk.
The second big thing I see coming is autonomy. The Secretary of the Air Force, I think, was speaking today and kicked off talking about, it was actually one of my guys, took him up in an F-16 at Edwards that was flown by a robot. And they did dissimilar air combat training, basic fighter maneuvers, dogfighting. And, with respect to the pilots in the room, the robots are already kind of winning. And so he came back and said, I want to do this faster. So we have a variety of programs on autonomy, air, sea, land, undersea. But in this instance, I'm talking about in the air. Actually, not just an autopilot to drive you around, but to actually work the radar, work the missiles, react to threats, and actually understand the mission. That's called ACE and air. And then I think, if you ask me when 100 years ago, when you got in an elevator, there was a person whose job it was to drive the elevator. And that was actually kind of a glamorous position. They didn't wear silk scarves and leather jackets, but it was kind of a good job, which now you don't use that. I think in 100 years, while there will be recreational aviation with human driving and aerobatics and stuff like that, I think it'll be a very rare day indeed when someone, as a matter of business, actually has a human driving. And it pains me to say that, but it's obviously coming.
That's fantastic, because at the end of this panel, what we're going to do is ask all four experts to paint that picture 100 years from now, literally, how will we be flying? But before we get there, Amy, you mentioned the adaptive engine tests. And I think when people think of GE, it's a massive company. We think of a lot of things, but not everybody knows that you're in 2/3 of every engine in the world. And so you have a deep aviation history. What is the adaptive engine tests that you've been working on, you mentioned? And what's sort of right on the edge of your tech map personally that you want to pursue?
Sure. So first, I failed to mention up front, we have a special place in our heart for Secretary and Dr. Carter. He served on our board, and I think this event is a really great testament to him of how we're connecting the conversation of technology, innovation, and frankly, policy and leadership, because we do need great leadership to take the technology where it needs to go.
So much.
So if I go back to adaptive, So it is truly the next generation leap in combat propulsion technology. The third stream of air gives more cooling. We all know that these platforms have more power needs, more cooling needs in order to do the mission systems and weapons on the aircraft. But then also the ability to accelerate and then get to a cruise efficiently like an airliner. And that really is the differentiation on range, on power, on thrust. That is, 25% better than what we can do now. And that's what we need as we think of the missions, obviously in the Pacific, but then other missions around the world. So that's what's unique and special. And then we think about the advanced control system that was required, but also the materials. So I think material science continues to be an area in which GE are spending a lot of investments and money, and has been a differentiator. As we think about the missions and the environment that the panel's already touched on, we're going to need continued advance in material science. And frankly, those material science are not just for propulsion, but electric power. So if you think about hybrid electric and even the needs for a contested logistics environment, that's another area where those investments we're making applied to advanced adaptive engines, applied to hybrid electric, even applied as we think about our sustainability mission. So if I go out to 2050 on our commercial side of the business and sustainability and the importance of that technology for the flying public, you're going to see a lot of material science advancements.
That's fantastic. Mark, the Skydio is an American competing drone company. At the edge of your tech map, in your sphere of control, what are you guys pursuing? What do you see as next?
Wow. Yeah, another great question. Believe it or not, I think the autonomy stuff is there. I mean, we're already doing that with GPS, without GPS, in very difficult contexts, whether that's in combat, whether it's in tight spaces, day, night, etc. So I think that's good. Where I see the real kind of edge of the boundary are improvements, kind of like what Amy said, in battery technology, to have an energy-dense capability to carry one's own power, because right now our primary limit is in endurance and in range. Now we're somewhat solving that with collaborative tactics, where one drone can signal to another, I'm getting low on power, I need you to come take over. Autonomously, drone 2 will go out, align sensors, take over responsibility, communicate to drone 1, go home. That works, but now you have to have a bag of batteries or some kind of charging mechanism just to keep feeding those 2 drones batteries. So we can somewhat solve through tactics the endurance problem, but I think that is going to be an enduring issue to get that. And then the next area, I think, is really secure and resistant comms.
Yeah.
And the reason I think that is so important is, at the end of the day, human beings will not trust the technology unless that they have some form of control over it. And we already have the capability, like today on my phone right here, if you want, we can fly a drone in California 3,000 miles away using my cell phone, and we're using LTE and 5G to do that. But if you have a mission critical need, are you going to trust just the basic cell phone network? Probably not. So I think the comms are going to be a really, really important part of creating human trust so that this proliferation that I've described will ultimately happen.
Makes so much sense. There's so many battery trends and energy trends that would be interesting to see how those come to autonomy and change the game and endurance. And certainly the Russians are taking away communications for autonomous aircraft now too. So it's
indeed.
Yeah. Sassie, maybe you could just take a step back as we think about what's on the edge of Venus and beyond, to almost teach the audience here a little bit about how your engine is so unique. And, even if you were to break it down to an 11-year-old out there, how would you explain how your engine is so different? And then what's next for Venus?
Yeah, thanks. So what I like to do when I'm talking about what Venus is doing is use a water bottle. And so rockets, the rockets that SpaceX uses today, or, really that Apollo used 50 years ago, it almost hasn't changed. Those are all deflagration engines. And so typically it's about 90% propellant to, get a payload to space. So we're commercializing the rotating detonation rocket engine. So detonation is supersonic combustion. And so if I was to use this engine for an orbital rocket, theoretically, I would need to be about 67% mass fraction. Well, that is a drastic amount of payload that we could, send extra things to space. Well, we happen to come from Virgin Orbit, where our company went bankrupt. And so we did not want to be the 101st launch company trying to send things to space. But we looked at the market and said, like, what could this engine actually be used for beyond just orbital launch? And so our entire premise is, instead of, sending extra payload to space, what if we turned our rocket this way? We added weight. We used some of this mass for wings, landing gear, and you could actually make the X-15 a reality. So we're really giving the X-15 an engine upgrade such that it can create reusable hypersonic vehicles. So at the core is that rotating detonation rocket engine. And our team, we come from SpaceX, Virgin Galactic, NASA, Blue Origin. Like, they are some of the world's best rocket scientists. And we have been, we grabbed a technology that was proven in, an academic lab, and literally grabbed it from low TRLs and have been commercialized, pulling it up. And so we're a venture-backed startup. We're at the Houston spaceport, and I gotta say, God bless Texas. We were literally firing our rocket engine outside of our hangar door in the middle of the city. And so it's been, it's been incredible progress to take it from nothing 3 years ago to, a working engine that, how can we now integrate it into, the next generation vehicles? And so that's why we should have a good conversation about it.
Yeah. Sassie, just a quick follow on. If anyone in the audience here was to take a hypersonic flight to another part of the world, what speeds can a human endure? Have you guys explored that?
Well, I mean, what do astronauts endure every day, right? So
1,000 miles an hour.
17,000 miles per hour. So, humans, and I am not a fighter pilot. These guys are probably much better at telling you, humans are much better at taking G's into their chest than down. And so, we have worked, one of the joys of being in Houston is we've got Johnson Space Center just down the road from us. So we have had their human factors and flight team look at our trajectories and say, hey, does this work? And they said, yeah, there's no problem at all. And so, it's not like we're taking someone and blasting them to high speeds. It's a gentle climb. We're very good, slow acceleration up to the speeds at which we can then use to go across the globe.
Fantastic. Taz, you just explained a little bit about what's sort of on the edge, is what Advanced Research Projects Agency is all about. If you were just to go beyond your agenda, so of your reign and TTO, if you went just out here, use your imagination, what would you shoot for?
Well, I realized with my elevator analogy, I was trying to make aviation boring. That wasn't intentional, but that's kind of a thing, I think. But, between the autonomy, the advanced aerodynamics and the energy, as you're pointing out with the battery, you kind of need all three of those together in order to really transform aviation. And, I will say that, we are looking at rotating, detonating, ramjets.
Yeah.
So not rockets, and a bunch of space stuff that I'm not talking about today, but, I do see kind of the convergence of the two. If we can get around, we're actually looking, we have one program, something completely different, looking at beaming power to a drone to keep it aloft with an energy source on the ground. The program manager's sitting right there, so I had to say that out loud. But skepticism's warranted. Hydrogen, if a lot of people are interested in hydrogen, you could fill a C-17 up with hydrogen in all its gas tanks and all its cargo space, and not go as far as you would go with hydrocarbon in just the gas tanks. So, it's hard to beat chemicals, and I think we're probably going to be using that for a long time, barring, Mr. Fusion from Back to the Future or something, coming up.
1.21 gigawatts.
Yeah. But I do think there's a convergence there, and I think that allows you to scale in two ways. The autonomy allows you to scale the human element, to train a top flight, weapons school or Top Gun instructor pilot, weapons officer. It's probably $20 to $40 million, and that's one human being. And if I could take all that knowledge and then print CDs, that's transformative. And the same on the aircraft. I talked a little bit about, one of the things we're doing on my seaplane is trying to make it affordable. figuring out how to build these things affordably is really important. And some of the smaller companies, since they're so close to the bottom line, are really doing good work, I think, in getting close to that.
Maybe in the spirit of the Expo, we should mention other forms of aviation. You mentioned hydrogen. There are passenger hydrogen aircraft that have been tested in the United States. The exhaust of those is pure water. So that is out there. We've also, there is electric takeoff and landing aircraft out there as well. So there's other branches. But maybe just a quick question before we wrap up with a true vision of the next 100 years from each of you, is maybe how AI is intersecting with your technologies. I know, Amy, you've mentioned the materials world. I know you have an amazing lab that I'm not sure if everybody's familiar with, but it's DARPA-like, if you will, and your own lab. So how's AI intersecting with your portfolio?
Yeah, so I would say GE is really using AI to disrupt itself. And you're referring to our Global Research Center up in New York. And we are actually partnering with DARPA on training an AI to have childlike learning ability. So we're training it, can it learn just like a child and then continue to mature in its learning? And we're using those same scientists back in the material science world to disrupt themselves and come up with new formulations. And then you couple that with advanced manufacturing techniques, additive robotics, even different inspection techniques through UT or CT, but think advanced there. We're very lucky. That center is really, truly designing things for 20 years out.
Fantastic.
And so we're lucky we have that peek into to what it can be, what the art of the possible is. And we're using it to disrupt ourselves. And even in AI, I see my CIOs in the audience, and she spoke on a panel yesterday. We're partnered with Palantir, and we have multiple teams within the company, multiple different functions. We're sponsoring their AI work, and they've done things to disrupt validation and verification of a traditional system, which can take much of the time needed. They're disrupting our engineers and their own design techniques. So we're challenging ourselves to think differently, not just be a big 100-year-old company, but position for the next 100
It's fantastic to see you reinvent yourself for a company that has survived well so long.
Mm-hmm.
You know, Mark, someday you would dream of Skydio being like Tesla, where the iOS would just download, you'd get these upgrades. I mean, how is AI either in your platforms or around your platforms?
Yeah. So we use AI in multiple ways. The first is in that foundational thesis of Skydio. How do you abstract away the hard piloting skills? Well, the way you do that is you create an obstacle avoidance system on the aircraft itself. So all of our Skydio aircraft have 6 fisheye navigation cameras. These are commercial off-the-shelf cameras. But we have created, they're like 9 neural networks running on the edge on the device that create an obstacle avoidance bubble around the vehicle. And that's why, like, if you tried to drive it into a tree, it won't go into the tree. It will find a way to navigate through the branches on its own. So that's how you make it much easier to fly. The second area where it is already on board is in the navigation system. So that's what allows us to navigate without GPS. So when GPS is denied, our drone can still find its way home or complete its mission, whether that's a scanning inspection mission, an ISR mission, what have you, flying waypoint to waypoint. And it's essentially using a technology called VIO, which has actually been around for a while. But when you can couple that with computer vision models, so I've flown a certain distance, I've mapped out where I was, now I can use that same technology to find my breadcrumbs back home using that same technology. So those are areas where it's already instituted. We also have some basic computer vision algorithms running on the edge on the device, so whether it's connected or not, so that the device can track, classify, and in some cases identify certain things, whether those are people, vehicles, etc., and now lock that subject in the subject camera and track it, much like we would do with a targeting pod back in the day, but we had to do that manually. So this can be done automatically. We also have customers that are loading up their own computer vision models, so third-party algorithms at the edge. For instance, electrical power companies doing autonomous inspections of their infrastructure. So what does a good insulator look like on that? What does a bad insulator look like? And now, do you really care as the human look at the pixels? Probably not. You just need to know there are 4 bad insulators on this piece of electrical infrastructure, and it's these 4. That's what you care about.
Helpful.
So those are some of the areas where we're already doing it.
So clear. Sassie, I know that there's a material science that's really under your control, and you're really into hardware. But maybe in this, you could tell everybody, without being too detailed, I know that some of it you need to protect, about just how you've printed some of your engine and where materials are going that way. But also, there's a material science in your company as well, isn't there?
Yeah. So, one of my favorite analogies for rockets is rockets are the equivalent of lighting a fire in a wax fireplace, and you have to keep the wax from melting. So at the core of our technology is how do we keep this engine cool? And so it's absolutely a material science challenge. And so, that if I had pitched 3 years ago, as we were, 2 people in a PowerPoint presentation with this crazy idea, our entire pitch was around how do we keep this engine from melting? And this is the way we think we're going to do it. And sure enough, we've done it. And so, we've got some of the world's best aerospace manufacturing engineers, I believe, on our team that have figured out how to actually go make this work.
Fantastic.
And I do want to go to AI because I was thinking,
yeah, please.
I was ready for the AI question.
Yeah, please.
Threw me a different bone.
Please.
But what our whole philosophy of Venus is build a little, test a little, learn a lot. So the faster that we can iterate on that testing speed, the faster we get something to market. And, again, as a limited resource, venture funded company, we've got to get to market fast because at some point our investors are gonna like run out of patience. And so we recognized early on that having powerful software teams and software integration into our hardware testing was key to go from running an engine test to having the data automatically, quickly analyzed such that our propulsion engineers can make super fast decisions, make changes, go right back to our manufacturing engineers, make a change, and get that back on the test stand in less than a day. And so, using AI and software to power that cycle has been crucial to the speed at which we've been able to operate.
Fantastic. Sounds like the new cycle of innovation to me. I love it.
Yep.
Why don't we turn, just for everybody in the audience here, and just begin to think about, we've set the stage of how much can change in 100 years. All of you have been really clear about the tech under your control, how that's going to affect flying. I mean, starting with you, Taz, and just coming down the line here, if you were to really go forward, you've started to talk about it, but paint us a picture, give everybody just a picture call of how will we be flying 100 years from now, in your view, your grounded tech view of real flying 100 years from now.
Oh, God, I was expecting the AI question, too. And I got an answer for that, not this. Look, I do think that we're going to kind of commoditize aviation in the way that you've kind of commoditized ground transport.
Yep.
It's just a thing that happens that you do. And from a military perspective, the harder things that I think we'll get at, but that are hard right now are, I'm going to go back to autonomy, sorry. When your Tesla self-driving car, when it kills someone, it does it by accident, right? It's not what it was supposed to do. It's really easy to say, don't do that. In an ambiguous situation with deception and jamming and everything, it's much harder. So we at DARPA in particular are spending a lot of effort on kind of the ethical, legal, societal implications of the stuff we're building. I really don't want to build Skynet. And so we're actually, almost the way you do systems engineering, we're at the front thinking this through to make sure that we're at least asking the right questions. And if we're doing something, we're doing it on purpose. The next thing I would say, once I actually have that capability to make intelligent decisions, I do think you're just going to give your AI kind of what we would call mission type orders. Hey, protect my right side. You're not going to program it. You're not going to tell it what to do. You're not going to hand fly it. You're just going to tell it what you want it to do, and it's going to do it. And I do think that's coming. And I do think the aircraft will be specialized and will be, we kind of talked a little bit about adaptive engines. I think the whole airplane will probably be kind of adaptive. And, able to optimize for a particular function and then change to optimize a different function. And I think, if you watch like science fiction, there's just little robots floating around doing things and nobody's even paying attention to them. And I do think you could get there if we can solve the energy and autonomy stuff.
As a good picture of 100 years from now. Thank you so much. Sassie, you're sitting on the hypersonic economy. 100 years from now, how are we flying?
Oh, fast. I think for sure, it wouldn't be a stretch to, get from here to the other side of the world in an hour. Like, I think that's the norm. Our ultimate vision is, every time we've seen increases in transportation speed, whether we went from railroads to cars to, propeller engines to jet engines, every one of those advances in speed has actually increased peace and prosperity. And so our vision at Vetus is, how does the world change if we are globally connected? What happens if Australia is now only 2 hours away? What trade? So I envision a much more globally connected world because of aviation and the connectivity. I think we learned a lot in COVID. I mean, there's power in face-to-face. It's nice to be on a stage with folks together, and you can only take so many Zoom meetings. And so, I believe in 100 years, it's no big deal to have a meeting on the other side of the world, just hop back and forth. I also think we didn't talk about space, but, I think the world will change drastically because we'll be either multiplanetary. There's so much going on in the rest with advances in aerospace and aviation that will impact, Leo and beyond.
Such a good picture. Mark, you devoted yourself, I think when you were jumping into a Viper and you're current qualified, it would have been hard to see Skydio. And now here at Skydio, if you just go another 100 years for us, what do you see?
Yeah, well, I actually agree with both what Ken and Sassie said. I see the commoditization of, I call them aviation things. And I think we've already seen this journey. I see people holding cell phones in their hands. So there was a time when you had a computer and it was a really big thing and the chip was right there. And by the way, you had to be really smart and trained in order to use that computer. Then we got smaller devices. We could carry them around, but the chip was still in it. So all your compute was there. And we live in a world today where with the devices we hold in our hands, yes, there's some compute happening on there. And by the way, you don't have to be very well trained. I mean, a 3-year-old could pick up an iPhone and make it do whatever they want. But a lot of the compute is happening on commoditized hardware, and you don't care. You really don't care. You only care that you have access to the thing, the information, whatever it is that you want, right? And that is cloud computing. So I see a future where in the physical world, where we're in this transition now, we will be there. And much like what Ken said, I see a world where you'll have a question, you'll have an information desire or an effect that you need to accomplish on the world, and you will say it, you will think it, and that will be transmitted into a blob. I don't want to use the word cloud. This blob will be in the physical world, and 3 or 4 flying intelligent robots, which is what we call them in Skydio. We don't call them drones. Some of these intelligent flying robots will go, hey, I can pick up a part of that person's intent. The other one can go, well, I can take a picture of the other part of the intent. And the other one goes, oh, this person also wanted a piece of mail delivered. I can deliver that physical object. And this will all happen with, like, you'll be 5 layers of abstraction away from all the decision-making that is going on there. And if you listen to, I think, every thing that everyone in the state said, it is adding up to a future that looks like that. Now, I personally think that is going to be a wonderful future. I think the humans will always fly in airplanes, but much like Ken said, it will be because we as humans want to experience the thrill of flying. And with all the additional time we have, because we're not stuck with the dull, drudgerous, dangerous tasks, we'll all be able to do that.
That's a good vision of 100 years from now. Thank you so much, Mark. Amy, you have a massive enterprise in front of you and a great mission. If you were to daydream for 100 years from now, what do you see?
Yeah, they've said it well. So I'm just going to build on that with a few key themes. So first, I think it's more sustainable future. I think we are going to use the technology for the good to make life on this planet sustainable. I think we'll also use the technology for the good to advance, our own prosperity, as well as connection and peace. And I think we'll engage the youth in ways we haven't before, because I think that all this free time will enable us to do that. Of course, there'll be a 3rd generation of the adaptive engine by then too.
Fantastic. At SCSP, we look at the four of you as holding a little piece of the innovation ecosystem in your hands. So when we leave this event and you go
no
back,
pressure.
yeah, but I
No
mean,
pressure.
but you're doing it, and so I know at the project, we want to thank you. If I could please ask the audience to thank our experts for a wonderful panel. Thank you so much. Thank you. Thank you so much.